Very good morning to all of you. Today we are going to start the Chapter 1 Coordinate System for the Engineering Mathematics 3 BEE 21503. Okay, coordinates are an ordered set of values which specify a location relative to some origin. The order of coordinate is important. There are a variety of coordinate systems. We have 2D and 3D coordinate system. A 2D coordinate system used to specify in 2D space, while 3D coordinate of course is 3D space. Then we have the three types of coordinate system, four types: Cartesian coordinate, polar coordinate, cylindrical, and spherical. So Cartesian coordinate, also called rectangular coordinate system. Okay, we have 2D and 3D Cartesian coordinate system. Okay, for example, this is a 2D Cartesian coordinate system. This point P1, 3, 4. With x is 3, position x is horizontal. Y, from y here, this is 4 units, so 3, 4. Okay, the order of the coordinate is important. And here 3, 4. This show x is -1. -1 will be your left hand side. -3 down, so y go down 3 units, so this -1, -3. In Cartesian coordinate, you must have x first followed by y, and the order is important. 3, 4 is here, 3, 4. 4, 3 means x 4, 4 unit, y is 3 unit in here. So it's totally different locations. Polar coordinate, you have the r and theta. R is actually radius. Okay, we measured up to origin. It's like radius of a circle. Theta is actually positive theta. Means we measured the angle from positive x-axis anti-clockwise. Negative theta will be clockwise. This will be negative theta. So like here. Okay, if r theta is here, negative r theta means reflects it at the origin, will be here. Okay, and we have quadrant 1, where x positive, y positive. Second quadrant, x negative, y is positive. Third quadrant, both x, y negative. Fourth quadrant, x positive, y negative. So example of the coordinate system: 1, 5, 5, 0, 4. Okay, if 5, 5, 0, 4, this is the angle 5, 5, 4, and we measured here from origin. This is 1 units, 2, 3 pi. So mean is 2. Okay, 1 unit, 2 unit. Okay, 1 full cycle is 2 pi. So another half circle. So mean here is 2 pi. Add up 1 more pi. So 3 pi. So this 2, 3 pi. 2 negative 2 pi over 3. 1 unit, 2 unit. So this one measured and clockwise for the angle 2 pi over 3. So -3, 3 pi over 4. If this is angle 3 pi over 4. Okay, and then from here we draw. Okay, extend your at the same angle you extend the line. So 1 unit, 2 unit, 3 unit. So this will be the -3, 3 pi over 4. So that's it. Positive angle is counterclockwise. Negative angle is clockwise. So now we would like to change from Cartesian to polar coordinates. So you have, this is the angle theta. R is actually the radius. Okay, this is actually you have this is the x horizontal. Okay, this is vertical. You have y. You have this xy in Cartesian. We would like to change it to r and theta. So from the xy, this point, connect up to your origin O. So this will be your R. So we would like from xy, okay, Cartesian coordinate or rectangular coordinate to convert it to r and theta. So we need to measure what is this r, what is the angle theta. Okay, by Pythagorean theorem, you know, okay, x and y making an 90 degree. Once you can find r using Pythagoras theorem, where the r squared is actually x squared plus y squared. And using trigonometric formula, calling tangent theta will be y over x. That's why theta is arctan y over x. So hence to find the r taking the square root, so r will be sec x squared plus y squared. So if you want to convert from polar to Cartesian coordinates, okay, as you know, this is x, the vertical length is y, this will be the r, here is a theta. Taking the sin theta, we have opposite divided by the hypotenuse, which is r, so y over r. That's why r will be y, that's why y from here. So y will be r sin theta, taking cos theta, which is adjacent, okay, side divided by hypotenuse, which is x over r. So that's why cos theta is x over r. That's why x here will be r cos theta. So to given r theta, you want to convert to Cartesian. So y is r sin theta, x is r cos theta. Okay, we have the recall back some special angle, or you can use your scientific calculator to get this special angle value. Okay, as we knows that sin 30 degree or sin pi over 6 is 1 over 2. Okay, so this is a 90 degree triangle. Okay, this is a pi over 6. So over 6 here should be pi over 3. So I mean this is 30 degree, this is 60 degree. So we know sin 30 or sin pi over 6 is half. Half means opposite is 1, hypotenuse is 2. Using Pythagoras theorem, this length will be sec 3. Hence, sin pi over 6 is 1 over 2. Yeah. So cos pi over 6 will be adjacent and length sec 3 divided by 2. So if you want tangent, pi over 6, opposite 1 over sec 3. Okay. And then if you want sin 60 degree, will be this angle, will be opposite sec 3 over 2. So cos pi over 3 will be 1 over 2. Tangent pi over 3 will be sec 3 over 1. Opposite divided by adjacent. Okay, special angle for 45 degree. So 45, if this is 90 degree, 45 degree, this is pi over 4, this is pi over 4. So both, so this will, tangent pi over 4, we know is 1. So mean opposites and the adjacent will be same unit, which is, this is 1, this is 1. Pythagoras theorem, this will be sec 2. Hence, tangent pi over 4 is 1. So cos pi over 4, 1 over sec 2. Sin pi over 4, opposite 1 over sec 2. Sorry. This type of 1 over sec 2. So cos pi over 2 and sin pi over 2 is 1 over sec 2 or sec 2 over 2. Okay, now example to convert Cartesian to polar. For example, convert 3, 4 to polar coordinates. So you have, so mean x is 3, y is 4. To convert x, y to r theta. So using Pythagoras theorem, r will be sec x squared plus y squared. So plug in the x and y, you will get the r is 5. Okay, theta will be arctan y over x. So So 4 over 3. Okay, here. Let's skip my. Show my calculator. And then converts 8 pi over 3 to Cartesian coordinate. So you have, this is r is 8, theta is pi over 3. You want to convert back to x and y. So x is r cos theta. So plug in the r is 8. Okay, theta is pi over 3. So cos pi over 3 is half. That's why you get answer is 4. Okay, you may use a special angle, okay, that I gave you just now, or you can press your scientific calculator. If you want to use in pi, make sure your calculator is in gradient mode. I don't know how to escape this page so that I can show you the calculator. So y is r sin theta. So plug in the r and the theta, you get, okay, sin pi over 3 is sec 3 over 2. That's why you get 4 sec 3. So make sure you put it back. The answer, this is the x, this is the y, this is actually your r, this is the theta. Okay, and 3D Cartesian coordinate. So you have x rooms actually. Okay, the first room here where is x, y, z positive. So this is x positive, behind will be x negative, but y is positive. Okay, so this room will be, okay, x positive, sorry, x negative, y positive, z positive. Mean the upper level is z positive, lower level will be z negative. So total we got the x rooms, or we call x octant. Then, so in 3D, okay, coordinate system, we can have Cartesian coordinate, we can have cylindrical coordinate, or spherical coordinate. Okay, cylindrical coordinate is actually extension of the polar coordinate in 3D space. So you see, we still have the r theta, but z means r theta 0. It raised up to 3D, so become r theta z. So it's actually 3D polar coordinate where z maintain its value. So here, so this in 2D, we got the r, this is the theta. So in 3D, so means we raise up the polar coordinate to 3 space, it becomes cylindrical coordinate. Okay, it's spherical. Like this. Spherical, normally you deal with the spherical surface. If cylindrical will be normally cylindrical surface. So spherical surface, so mean actually you have a x, y, z. In Cartesian coordinate, you got x, y, z. To change it to spherical, it's actually from this x, y, z, you draw straight line up to the origin, but now it's in 3D space. So this point, okay, from the x, y, z to the origin, okay, this radius is actually radius of a sphere, or we call it, we put it in rho, because r we use for polar coordinate, so in spherical, we use a radius of a sphere as a rho here. Okay, and then you have, remember the theta, the horizontal angle. So in spherical coordinate also we have got the theta. Okay, the spherical coordinate actually we got rho. Theta is the same as polar coordinate and cylindrical coordinate. The new thing is the phi. Okay, phi is actually from your rho, phi making an angle with the z axis. And phi actually from the north pole, if you measure it from here along the latitude, and from the north to the south pole, up to here. So the phi from here, like if you have a orange or ball, okay, you will cut it to half. So measure from here up to here will be pi over 2. If you continue, if you got a full ball or full orange up to the south pole, so this will be from here to here half cycle, so it will be pi. So phi minimum from 0, maximum up to pi. So okay. So if you measure horizontally, this is a theta as we measured in polar coordinate or cylindrical coordinate. Theta 0 to 2 pi. So when like you have a ball, okay, you turn it horizontally around. You turn it, okay. You turn it like this, this one, horizontally, that will be the theta. If you rotate, okay, you measure from top here up to the bottom, this is the phi. So this is spherical coordinate. You have the radius of a sphere, which is rho. Theta, you measure it horizontally, like in polar coordinate or cylindrical coordinate. The new thing is a phi measured from the north pole to the south pole. So that is the phi. So you have rho. Theta is this one, phi is here. And then now, okay, we would like to convert from Cartesian to cylindrical. Then Cartesian to spherical, cylindrical to spherical. Okay. To convert from Cartesian to cylindrical or cylindrical to Cartesian. Okay, this one is like the 3D polar coordinate. Okay, up to this part is like your polar coordinate. The z maintained there. So this is from cylindrical, mean given r and theta. Given r, theta, z, we want to convert to Cartesian. So x is r cos theta, y is r sin theta, z equal to z. Okay, where the r is actually, r is sec x squared plus y squared from Pythagoras theorem. Tangent theta is y over x, z equal to z. If you want to convert back Cartesian to cylindrical, mean given x, y, z, you want to get back r, theta, z. Okay, example. Okay, convert 3, 4x. This is your x, this is a y, this is a z. You want to convert to cylindrical, mean you want to get r, theta, z. So r is a sec x squared plus y squared. So plug in the r, the x and the 4. You get the r. Theta will be arctan y over 8. Okay, z equal to z. So this is the answer. Okay, and then convert r, theta, z to x, y, z. Given r, theta, z. So x will be r cos theta. Plug in the r theta. Pi over 6, okay? Pi over 6 sec 3 over 2. In this one, you get sub 3 over 2. That's why pi over sub 3. Or may use scientific calculator to calculate it. So y is r sin theta. Sin pi over 6 is half. So 10 times half, you get 5. Z equal to z. And then put it the answer x. Y is 5, z is 3. Okay, now we would like to convert from Cartesian to spherical, later on spherical to Cartesian, and lastly 2 will be spherical to cylindrical, cylindrical to spherical. Okay, spherical coordinate. Okay, we have a point x, y, z. We would like to convert to rho, theta, phi. So phi is here. Z is a vertical axis. Rho, okay, is actually the radius. We measure from origin up to your x, okay, the Cartesian coordinates here. So this is a rho, okay, making phi. And in 2D, remember this is a horizontal length is x, vertical is y. So the hypotenuse here, or from the xy, you connect to origin. This is the r. Okay, r when you raise up to 3D space, so this is actually r. And r is actually making 90 degrees. So I put it here. So this is z. Z and r making is 90 degrees. So r is here, rho is here. Okay, let's on the next slide. So if you're taking sin from this triangle, sin phi, phi here over 6 r divided by rho. Cos phi, okay, the adjacent side z divided by rho. Tangent over 6 r divided by z. So to convert Cartesian to spherical, okay, in spherical, let's say you want spherical to Cartesian. Mean rho, given rho, if spherical, you got rho, theta, phi. You want to get x, y, z. You want to get x, y, z. Okay, how to get rho, theta, phi? How to get x, y, z? Okay, x from the polar coordinate, you know, okay, the x is actually from polar coordinate. Okay, from polar coordinate, actually your x is what? X is r cos theta, right? Sorry, here difficult to write. From polar coordinate, x is r cos theta, and then y is actually r is here, r sin theta. Using mouse, difficult to write. From polar coordinate, you know x is r cos theta, y is r sin theta. Okay, but in spherical we don't have r, we have rho. So you must find relationship of r and rho. So from this angle, okay, this triangle, this z is vertical. Okay, here, z vertical, rho is here, phi is here. Okay, r raised up in 3D, this will be r. So r here. Okay, taking sin phi as just now. Okay, taking sin phi, we have r over rho. So that's why r is actually rho sin phi. So replace here. So initially from polar coordinate, you know x is r cos theta. And r from here, r is rho sin phi. That's why your x is rho sin phi cos theta. So y from polar coordinate, you know, is r sin theta. And now r is rho sin phi. That's why y is rho sin phi sin theta. So from this triangle, taking cos phi, it will be z over rho. So z is rho cos phi. So mean given spherical rho theta phi, to convert to Cartesian, x is rho sin phi cos theta, y is rho sin phi sin theta. Z is rho cos phi. So you have to derive your own formula because normally during test we didn't provide any formula. And the opposites, if given Cartesian mean x, y, z, you want to convert back to rho theta phi. It means given now you have x, y, z. You want to convert back to spherical, which is rho theta phi, right? Okay. And then, as we know, actually rho is actually radius of a sphere, which is actually rho squared is x squared plus y squared plus z squared. That's why rho is square root of x squared plus y squared plus z squared. So it's one of the radius of a sphere. Okay, you want to find theta. Theta is from polar coordinate, taking the tangent theta y over x. So you got rho, you got theta. Okay, phi. Phi, you may take it from sin phi, cos phi, or tangent phi. Up to you, which one. Okay, example. Convert Cartesian coordinate 3, 4, 8. So x is 3, y is 4, z is 8 to spherical. You want to know rho, theta, phi. Okay, so from previous formula, so rho, third x squared plus y squared plus z squared, theta is arctan y over 8, phi, you may taking the cos here, so phi is arc cos z over rho. So you plug in x, y, z, okay, you get here, theta arctan y over x, so y is 4, x is 3. Make sure to get this radian, make sure your calculator set in radian mode. Phi, you may taking from here, cos phi is z over rho. Okay. So phi at cos z over rho, z 8 rho that obtained here. Or from tangent phi, looking back is tangent phi z over r. So sorry, tangent opposite r over z. So phi will be arctan r over z. So we will prefer this one. Because here you need to calculate back r. R actually x squared plus third x squared plus y squared, which is 5. So if we use a cos phi is z over rho. Since you have z already, rho you calculate here, so faster. So we prefer this formula rather than problem. We prefer this one. So put back the answer rho, third 89. So spherical, make sure this is rho, this is theta, this is phi. Okay, now convert spherical. Rho is 4, theta is pi over 6, phi is pi over 3 to Cartesian. Means we want to get x, y, z. Okay, remember, okay, x is actually r cos theta, y is r sin theta. And okay, taking, look back. Yeah. X r cos theta, y r sin theta. Taking sin phi, sin over 6, so r over rho. So r is rho sin phi. So that's why x is rho sin phi cos theta. So y r sin theta become r is actually rho sin phi. So rho sin phi sin theta. Sec, taking cos, cos adjacent divided by hypotenuse, so z over rho. So z is rho cos phi. So that's why x will be rho sin phi cos theta, y rho sin phi sin theta, z rho cos phi. Plug in rho is 4, phi P is the second argument, pi over 3, cos is pi over 6. Okay, you may use a scientific calculator or you can use a special angle that I gave in the previous slide. Sin pi over 3, sec 3 over 2, cos pi over 6, sec 3 over 2. So you got 4 times 3 is so 2 and 2 cancel. So this is 3. So y is rho sin phi sin theta. Okay, sin pi over 3, sec 3 over 2, sin pi over 6, 1/2. So you get answer of 2, 2, 4 cancel, sec 3. Z is rho cos phi. Phi is pi over 3. Cos pi over 3 is half. So you get answer is 2. So the answer x is 3, y is sec 3, z is 2. Okay, if you don't want to, you cannot memorize a special angle, you may use your calculator to calculate it. Okay, we have the last two, cylindrical to spherical and spherical to cylindrical. Okay, from spherical to cylindrical mean we got a given rho, theta, phi. This is spherical. Remember rho, theta, phi. We want to change back to r, theta, z. So notice theta maintained. We want to get r. Remember r is rho sin phi. So r, rho sin phi. The z is actually from z is rho cos phi. Means from the triangle up here. This one. Means we have a rho sin phi, spherical to cylindrical. We got rho theta phi. Want to change back r theta z. So r is rho sin phi. Okay, theta, and then z from here. Z rho cos phi. Okay. So spherical to cylindrical, r is rho sin phi, theta maintained, z is rho cos phi. Cylindrical to spherical, means given r theta z, now you want to reverse. You have the r theta z. You want to get rho theta phi. Right. So theta maintained. Given r, you want to get rho. Okay, remember rho is actually rho squared is x squared plus y squared plus z squared. X squared plus y squared is actually the r squared. So that's why the rho will be sec r squared plus z squared. Okay, theta actually same. Phi, okay, phi, remember, okay, taking cos phi is z over rho. That's why phi is cos z over rho. And rho is actually sec x squared plus y squared plus z squared. Or here, r squared plus z squared. Okay, example, convert cylindrical coordinate. Okay, 3 pi over 2 8 to spherical coordinate. Mean r is 3, theta is pi over 2, z is 8 to spherical. Then you want to calculate rho, theta same, rho theta phi. R is 3, theta is pi over 2, z is 8. To calculate the rho, okay, rho is radius of a sphere, okay, which is x squared plus y squared, or is r squared. Now we have r. So rho is sec r squared plus z squared. So r is 3, sec 3 squared plus x squared. We got cert 73. Theta maintain. R theta z to rho theta phi. So theta maintain, which is pi over 2. Phi, okay, from the cos phi is z over rho. Right? So phi is arc cos z over rho. And the z given is 8, rho we calculate here 73. So in radius. So put out the answer. We prefer this one easy because you already you have the if you want, you're using tangent. Tangent is r over z. So phi is tan r over z. R is 3. Z is 8. Also can. So either one. So the rho put back cert 73. Theta 502. Phi is 0.3588. Okay, the last one, spherical to cylindrical. Convert spherical coordinate. We have, okay, 4, pi over 6, pi over 3 to cylindrical coordinate. So rho is 4. Second one is a theta. Don't exchange it, then the answer will be wrong. Theta is pi over 6, phi is pi over 3. To cylindrical means you want r theta z. You want to get r theta z. Theta maintain pi over 6. So theta is here. You want to calculate r. R is rho sin phi. So rho is 4 sin pi over 3, which is cert 3 over 2. So you got 2 cert 3. Theta maintain. So r theta z. Z is rho cos phi. So rho is 4. Cos pi over 3 is half, so the answer is 2. So put back the answer. R is 2 cert 3. Theta is pi over 6. R theta z. Z is 2. Okay, with this case, thank you for attention, and you may answer the tutorial questions